negative. So anytime you multiply two things that have opposite signs, your answer is negative. Anytime you multiply two things that have the same sign, it's positive. So I should have negative 15 up top. Any questions there? Are you sure? All right. That's correct so far, but what we need to do now is reduce the fraction. So this is this next step where we need to look at it and say, is there a number that goes into both of these, that divides in? Can you think of a number that goes into 15 and 36? 3? Okay, how many times does 3 go into 15? 5, so I can change that to a negative 5. And then how many times does 3 go into 36? 36 divided by 3, right? If you needed to, what is it? 12. That is fully reduced. Unless you can think of any numbers that go into both of these, but you're not going to be able to. That's it. That's our answer. So when we multiply fractions, all you do is multiply straight across. So if you like formulas, here's a formula. And this is only for the multiplication, right? If you have a fraction, let's say a divided by b, and I multiply that times another fraction, b over c. So I'm giving you like a generic formula now. The answer to this is just multiply the a times b, and then multiply the b times c. This is the easiest operation you can do with fractions, because all you do is multiply across top and bottom, and you're done. With some reducing, you might have to reduce. Okay? Here's your formula. I'm going to put the problem back up here. Same one. I want to see if anyone can tell me if there was something we could have done before we did the multiplication that would have got us to this answer even faster. Go ahead, sir.
You could divide the 3 and the 9.
Okay, so you can realize that 3 goes into both of these, right? 3 goes into 3 how many times? Once. 3 goes into 9 how many times? 3 times. And so now what we really have here is a negative 1 over 4 times a 5 over 3, right? That's really what that is. And now multiply straight across. Negative 1 times 5 is negative 5. 4 times 3 is 12. Same answer. Do you see that they both get you to the same answer? I don't care which way you do it, okay? I don't. Just be able to do it. Hey, think back to when you were younger, when you were learning about numbers. 3 times 4. Did you learn 3 times 4 first, or did you learn 3 plus 4 first? Which one came first for you? They taught you how to add and subtract first, right? And then they did multiplication and division? When it comes to fractions, we always teach multiplication and division first. And we do the addition and subtraction after. And the reason is because adding and subtracting fractions is harder than multiplying and dividing them. So that's why we're doing the multiplication first. All right, so that's it with multiplication. This is obviously a review. I mean, this is arithmetic of fractions. So let's go to the next topic here, which is going to be division. I'll put it here. Okay, so how do we do division of two fractions? Well, there is a formula, but I'll get to it in a minute. Let me first give you an example. So can we take this same example? Negative 3/4 divided by 5 over 9. Can anyone from your past experiences, math classes, whatever, anyone want to share how they were taught to do that? Go ahead.
How I was taught was you just take the second fraction and flip it.
Okay, you take the second fraction and flip it. Okay, so I'm going to take that and flip it, and then anything.
And then you multiply it.
You multiply instead of divide. So you do this. You're telling me you keep this one the same, right? Keep the first one. You're going to flip the second one over, 9 over 5 instead of 5 over 9, and then make it multiplication. Does that look familiar to you all? Yes? Did anyone learn this little phrase? Keep, dot, flip. Keep, dot, flip. That's the way some people have told me they've learned it. keep dot flip. So if you have division of two fractions, right? Here's a fraction, I'm dividing another fraction. What I'm going to do, keep this one the same, change that to a dot, and then flip. And now you're back to multiplication. So now we multiply straight across. So when I multiply, I get negative 3 times 9, that gives me negative 27. And then 4 times 5, that gives me 20. And then I look at that and I try and see, does that reduce? Are there any numbers that go into both of those? Other than 1, right? 1 goes into both of these, but is there any other numbers? 2? 2 doesn't go into both of those, right? 3, 4, 5. You could try on your calculator, it's not going to work. So that's our answer. Questions on that? Is this better than that weird crap I put up in the very beginning? Y'all feel better? Yes? I've done that in my calculus classes before. They've let me go for like 15 minutes. But that's a little different because calculus, you're expecting something weird, but still no one asked. I just kept on going and going and going. Maybe not 15 minutes, but felt like 15 minutes. All right. Earlier, who was it that said we could cancel out, do some? Can we do that here, though? We can't. There's a rule that we can't do the 3 and the 9. You're only allowed to do this canceling if you have multiplication here. So you have to do the flip first before you try and get anything to go away. Notice here, you can't get anything to go away. There's no number that goes into 4 and 9. There's no number that goes into 5 and 3. So there's nothing you can do. All right? You all right with this? All right, let's look at something else. How about, are y'all ready to move on? Oh, I didn't give you a formula, did I? Let me give you a formula. So the formula for this would be, some people just really like formulas, so I'm just going to give you the formula. Oh, on your tests, I allow you to have a sheet that you create that is front and back, where you can have any formulas, steps, procedures, whatever you want on this, but you can't have worked out problems. Okay, so like, you're going to have a reference. You're going to have to create it yourself, but just so you know that as we move on, that any formulas that I put up here, that's always something you can put on your sheet, all right? All right, so if I have a fraction, a over b, and I want to divide that by c over d, right? If I want to divide, then what that really becomes is the keep the first fraction, change it to a dot, which is multiplication, and flip, right? That's what that becomes. And then, of course, that is just multiply the tops and multiply the bottoms together. All right, just go a times d, b times c. And just, Diego, just so you know, that means for every, that is a mathematical symbol. For every epsilon greater than 0, this means there exists a delta greater. So I was actually writing real math, but yeah.
Real math?
That's real math, yes. Yep. All right, good? Move on. Oh, go.
Do you have a negative anywhere in there? You just carry it the same way?
Yeah, you just carry it. Now, that kind of leads to this question. Let's address this. We could have done this earlier. Let's do it now. Let's say you have a fraction with a negative on top, like that. Okay? When you have negatives on fractions, those negatives can live on the top, but you're also free, if you want to push the negative down to the bottom. These are equal to each other, all right? So any negative floating in a fraction can either be on the top or bottom, your choice. Or you can also pull the negative completely out in front of the fraction and look at it like this. Negative 4/5 is the same as 4 over negative 5, but that's the same as negative 4 over 5. So if I were to ask you to multiply, like over here, you could have put the negative on the bottom with the 4 and then multiplied, did your thing over here, and it would have still given you a negative, but the negative would be down here instead. So negatives can float. I don't think that's what you were asking me, but just so we're all clear on that, okay? Anything else? Do y'all want me to move to addition and subtraction now? Y'all ready to add and subtract? I realize that in high school they probably let you use calculators to add and subtract fractions, and that is not going to be the case here. So you're going to have to do this by hand, all right? So what if I take something like this, 3/4 and add to it 7/4? So, oh, we're in addition now, right? Ooh. Addition. How do you add fractions? Go ahead.
You add the numerator and you just carry the denominator over.
Okay, so you're saying you're going to add the numerators together. So you're going to take that 3 and add the 7. And then what are you going to do with the denominator? It stays the same. Okay? That is correct as long as
The denominators are the same.
they had to start out being the same. So in order to add fractions together, these two numbers must be the same. They have to be the same. If they're the same, then you can add just the tops together, 3 plus 7, and then you keep the denominator the same, right? You keep it the same. And if I do that, 3 plus 7 is 10. And then 10 divided by 4, I'm not going to get on my calculator and do 10 divided by 4. I'm going to try and reduce the fraction. What number goes into both of those? 2, right? 2 goes into both. How many times does 2 go into 10? 2 goes in here 5 times, and 2 goes in here twice, right? You have to have the same denominator to add two fractions together. Let's do another one. This time, I'm not going to have the same denominator. A half plus a fourth. I want you to add two fractions, right? That's what I'm asking you to do? Add two fractions? They don't have the same denominators, right? So you can't play the game we just played. But there is a way that you can get these denominators to be the same, right? We can do something called finding a common denominator between these two fractions. So I look at the two numbers, the two denominators, 2 and 4. I'm going to go through this kind of slow, like how you may not need to go through this whole process yourself. I want to make sure I show it. Basically what you're going to do is you're going to make a list for those two numbers. Here are the two numbers, 2 and 4. You're going to make a list of all the multiples of those numbers. So what are all the multiples of 2? 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 8, 10, 12, right? Those are all the multiples of 2. And then you list out all the multiples of 4. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 16. Do you understand what I'm doing here? What you're looking for is the smallest number that appears on both of those lists. So what's the smallest number on both lists? Smallest number is 4, right? That number is on both lists. And so what you're going to do is you're going to try and make both of those denominators be 4s. Well, this is already a 4, right? I want to make this one a 4. So the only way to turn a 2 into a 4 is to multiply it by 2. So watch what I do here. I'll do it in green. I'm going to take my 1/2 plus 1/4. I'm going to try and turn this into a 4, so I'm going to multiply the whole fraction by 2 over 2. 2 on top, 2 on the bottom. Why am I using 2 over 2? Whatever I do at the bottom, I have to do at the top, right? Really what I'm saying is, isn't this a 1? Isn't 2 over 2 1? So when you multiply a number by 1, does that do anything to it? Isn't that the property of 1, is that 1 times anything doesn't change that? That's why we're using a 2 over 2. Because technically, we're multiplying by 1, which shouldn't change what this fraction really is. It's just going to look different, all right? It's going to look different. It's not changing it other than the way it looks. So now, do you know how to multiply? Didn't we talk about how to multiply fractions earlier? Straight across? So what? Multiply those, you get 2 multiply those, you get 4, add together. Now they have the same denominator. Add them up. Keep your denominator. 2 plus 1, 3. Your answer is 3/4. Questions? I'm hoping this all looks familiar. Yes, I mean, maybe it's been a while, but look kind of familiar? Okay, before I get into another example, I just want to show you this problem again, the 1/2 plus a 4th, just to make sure you understand why it is kind of like what we're doing. Think of this as like a candy bar. This thing, I have half of it, right? That means I have a candy bar, I have 2 pieces, and I'm only going to take one of the 2, right? So the number on the bottom is how many pieces you've cut the candy bar into, 2 pieces, and the 1 is how many of them you're taking. So I'm taking one of those 2 pieces, and then I'm going to add to that. Now I take a candy bar, I cut it into how many pieces? How many pieces?
4.
4. The bottom tells you how many pieces, so 4 equal pieces. And I'm taking one of them. If you were to add that together, think of a candy bar here. I take this would be half of it, right? And then I add this much, that would be a 1/4 of it. Does it make sense to you that we get 3/4 of the candy bar? Okay, that's just a visual, like what's going on here. I wanted to show that to you because I want to make sure everyone in this class is comfortable with this idea. What is 0 divided by 5? 0. This is 0. Why? Think of the candy bar. I have a candy bar. How many pieces am I cutting it into? How many pieces am I cutting it into? 5 pieces. 5 pieces. How many am I taking? None. So how much do I have? None. What's 0 divided by 4? Same idea, right? Cut the candy bar into 4 pieces. Take none of them. You don't have any then, right? But what about this? What about the other way around? So I have a candy bar, right? How many pieces am I cutting it into? But I have a candy bar, so that's at least 1 piece, right? The candy bar itself is 1 piece. So I'm supposed to make no pieces and then take 4 of them. Does that make any sense? Which is why this is, I heard someone say it earlier, a minute ago, this is called undefined, right? Back in your math days at some point, I'm sure some teacher somewhere told you that you can never divide by 0, right? You can never divide by 0. It's undefined. The reason is because of this idea of like this fraction, candy bar. The denominator is how many pieces you have, cut it into, and the top is how many you take. So it's okay to have 0 on top, but it's not okay to have 0 on the bottom. How we doing? You hanging in there? How much time is that? This class goes by quick. Let's just do a formula for this. Believe it or not, there is a shortcut formula for addition. There's a shortcut formula. Students love this when I give it to them. So let's say you have 2 fractions, a over b plus c over d. We're trying to add 2 fractions together. Well, these don't have the same denominator, right? They don't? So I would have to get a common denominator, then I could put them together. There's a shortcut, a way that you can get the answer without doing any work. Well, not much work. It's a times d plus b times c, all divided by b times d. Now, I know that formula looks terrible. I want to show you it in action on an actual example, and then you'll see it's not that bad. Let's take the one that we had a second ago. Okay, let's do that problem, but let's do it with the shortcut. So the first thing I'm going to do is I'm going to take this a and multiply this d. That means I'm going to multiply these two numbers together. So what's 1 times 4? 4. So I'm going to put that in the top left corner. Then I say plus. Now I'm multiplying the b times the c, which is these two multiplied. So multiply these two now. What's 2 times 1? 2. Y'all following what I'm doing? And then divide that by, now finally, BD is these two multiplied. So I'm multiplying those two together. 2 times 4, 8. Y'all see how that worked? Those two plus those two divided by those two. What is this? 6 over 8, right? That's not the answer we got a second ago, right? Our answer was 3/4. But you can reduce that, right? 2 goes into both of those. 2 goes into 6 3 times. 2 goes into 8 4 times. So you get the same answer. Yes?
That's called cross multiplying, right?
No, that is not called cross multiplying because what you're thinking of is if you had something like this. If you had something like x over 4 equals 3 over 7, then you can do a cross multiplication like this. That's when you're working with an equation. You can do a cross multiply. But this is not an equation. This is just adding two fractions together, right? Add these two. So we're using a formula. I know it looks like cross multiply, but it's not the same thing.
Okay.
Yeah. Good question. What else? Anything else? We only have 5 minutes left. So what I'd like to do is I'd like to put a few problems up here. We haven't talked about subtraction, so this is just going to be addition. We really are just barely getting into the material. So I'm just going to give you a few problems for you to do for homework, all right? Just make sure you bring those for next class. And then next class we'll have the full class to really just, get through this material. So homework. Number 1, let's go 4/7 divided by 2/3. -5 over 12 divided by 6 over 5. I'm going to keep it simple tonight, or today. Let's go 1/3 divided by 3/7. I'm just going to give you 6 problems, all right? The next problems are going to be all of those problems with addition between them. Right? So I want you to divide all those fractions, and then I want you to add all those fractions by hand. Okay? So if you're going to use the formula, but let me see you use the formula. Don't just give me an answer. Yes?
Why did you write 1, 2, 3, 6, 7, 8?
That I can't explain.
6, 6, 7, 3. I was going to say.
Yeah, no, I have no idea why I did that. I think I was thinking in my mind, just for that second, I'm going to give them 6 problems. And I wrote 6. I'm losing it. It's day 1. Give me a break. Okay, understand? Bring that to class next time so that way you can say, yeah, I was able to do that by hand. Going and punching this in on a calculator and getting answers is not what I'm looking for. All right? Bring it with you. I could count that as a quiz grade. I'll hang out for a few minutes if anyone has any questions. I'm going to let you go a little early so I can answer questions if anyone has them. If not, have a good rest of your day. I will see you all Wednesday.
So that math packet that you were talking about, we don't have to get that, or do we need to get that? Because you said sometimes you post it on that.
I might tell you to go do something from it, but I have it electronically.
Okay, on Canvas. And
Canvas, so you can just open it up and look at it. You don't need a physical copy of it. Yeah.
And then also my advisor told me to take this class because I'm a psychology major. That's
Okay.
still fine, right?
Yes.
'Cause psychology is not really like
Should be,
medical math.
should be. Let me look over here. There's a thing where we have a chart that shows, I think it's, go ahead. And let me turn this camera off because it'll just keep going.